Hi, everybody. I am Matthew Jones. I am the Chief Architect and Distinguished Engineer for Ansible Automation at Red Hat. I have been with Ansible almost since the beginning. It'll be 10 years next month that I've been working with Ansible. And my original job was to build Ansible Tower. So if you've used Ansible, maybe you've used AWX, maybe you've used Ansible Tower. What I do today is explore new initiatives and new systems and new things that we could invest in, and we might bring more value and add more benefit to Ansible as an ecosystem. And so today we're going to talk about Ansible Lightspeed. Has anybody here used Ansible Lightspeed? Has anybody used Ansible? There we go, nice. So I really like this graphic a lot. We showed it at Ansible Fest and Summit last year. It's very swoopy and nice. I will say, Ansible Lightspeed with IBM Watson Code Assistant, you can use this today. It's available in a community form. It's, you use it through VS Code if you're writing Ansible content, writing Ansible playbooks and Ansible roles. You can actually make use of this today. And what I'm going to talk about today is what Ansible Lightspeed is, how it's built, how it's hosted, and how it works, and where we might go with it in the future. Before I move on to the next slide, though, and dive into that, I want to cover some of the design principles and sort of the fundamentals of where we wanted to start with Lightspeed. At its really basic level, it's an auto-completion system in VS Code for writing Ansible. It's not anything earth-shattering. It's not going to write term papers for you. It's not going to write songs or poetry. It's not going to write books. It's designed very specifically to help you write Ansible tasks and Ansible playbooks. It's designed to lower the bar for producing automation using Ansible. And so there were a lot of hands here that used Ansible. Sometimes writing tasks and writing Ansible playbooks can take a while. Like it's YAML, and we talk about how disgusting it is to write automation in YAML, although I remember what it was like to write automation before Ansible, and I'd rather not go back to that time period. But it's sometimes still difficult to find the properties and parameters and the expectations of the modules needed to actually run the automation. If you're going to create an EC2 instance on Amazon, or if you're going to install Nginx or Apache and configure it, open firewall ports, you may know how this works. And Ansible is easy enough and expressive enough that you could figure it out and read documentation. But what if we had a tool that could get you 90% of the way there? And that's kind of what Lightspeed is. You're writing in VS Code or in your text editor, and you're like, I really need to open this firewall port, but I can't remember, is it firewall D or IP tables, and what's the incantation, and do I make it permanent? Ansible Lightspeed is there to help you with that. It is trained using content from Ansible Galaxy and Automation Hub, and so it's benefited from all of the community contributions that have come before it. And that's what makes this different than the other systems that you see today, like Copilot. This system is specifically designed for one purpose, and that's to make it easier to write Ansible automation. And true differentiation in this space is more than just a language model. When you look at Copilot and other systems like that in Ansible Lightspeed, you're not just interfacing with the language model. You're interfacing with a whole pipeline of things that contribute to taking the knowledge from the language model and delivering it to you in your text editor. And so we had the language model. A couple of years ago, we went to Yorktown Heights, IBM's research facility, and they were like, we have something really interesting to show you. And they showed us this language model. We were like, that's cool, but how do we plug that into something that a customer can use, or that a user can use? We need to build a system around it that allows us to do that. And when we started with our prototype, we were just, here's a VM and torch serve and Django, because we're a Python shop, and we put that together and it worked pretty okay. But we decided this needed to be faster. It needed to be easier to train the language model. It needed to be easier to serve it. And so us and our partners at IBM Research, we got together with the OpenShift AI team. It was called Red Hat OpenShift Data Science, or ROADS. I'm glad we changed that to OpenShift AI because it sort of rings a little better. And we built this service where we can onboard models really easily. OpenShift AI and watsonx. watsonx is the model serving runtime. And then we build some of these other components like the wisdom. It says wisdom here, but we call it Lightspeed now. We build the VS Code plugin. It already exists. You can use it today. It helps you look up documentation. It does auto formatting and all of these nice things. And we can, since we already build that thing, we can integrate Lightspeed right into that. And the Wisdom or the Lightspeed web service is the point at which we do the transformation and modification of the data coming out of the language model. One of the real issues with training data, and you see this with Copilot if you go and try and get it to write Ansible, is that the corpus of data that we've trained our language models on, sometimes it's old or it gets the formatting wrong or it's not following Ansible best practices. So what the Lightspeed web service does now is it transforms that data to fit the current best practices and models that we use within Ansible to write content. It makes things look nice. It also filters out any secrets or protected data that might fall into the output. And it uses the context provided by VS Code to inform what variables and parameters and things you might want to fit in that model. And all of this is this sort of nexus point where things just get easier to use. The goal here is to lower the barrier, to lower the bar to writing Ansible code. And so IBM, when they were first piloting this for us and we were first developing this service, they wanted to understand how much easier it was to write Ansible for somebody who had never written Ansible before. How much easier was it to write Ansible with Lightspeed? And they came up with this. It reduced playbook development effort by over 50%. And I think there are a couple of metrics that go into that. But if you think about this, I've been writing Ansible for 10 years. It may take me 15 minutes to write a playbook to create an EC2 instance and deploy an application. Maybe that takes me less than 5 minutes now. If you've never written Ansible before, something that might take you 2 hours of research, you could do in 15 or 20 minutes. There's a lot of value there. It's incredibly, it's an incredible boon to the efficiency. It's not writing songs or books. It's not writing term papers. It's not telling you vacation advice for traveling to the Bahamas. It's just writing Ansible automation. And this is where generative AI comes in with Ansible in very specific and targeted ecosystems. Somebody asked me the other day, what is the future of generative AI? It's enhancing this productivity. It's not the massive general purpose systems that we see in use today that we talk about in dystopian sci-fis or in the hopeful aspirations of papers from people who are building OpenAI and other systems. It's very specific tools used to enhance your productivity. It's very specific in its democratization of who can use a particular set of technologies to achieve a particular result. Now, when we built this, I can't give a demo because they didn't give me a stand here, but I thought I would show you sort of what this looks like from a meat and potatoes perspective. We'll cover what it does today, and I'll talk here in a minute about what it means in the future and where we're going to go with this. At a really basic level, you can install this right now and get started. Even before I'm through talking, you could probably be doing this. Generating tasks from prompts. Ansible content is really unique in that our best practices suggest a model prompt that is very suitable, the name field, in generating a task. And so this works today in task generation. Giving an example here, these are some of these things that, right, like this is kind of obvious in retrospect, but if you'd never seen Ansible before, you'd wonder what it's doing. Here's the other thing that's really important to us, and Jeremy sort of alluded to this. We have consumed community content to train our language model. It really kind of feels terrible to us to take all of that information and not give back to the person that has contributed their automation, their playbooks, and their tasks. When you are getting suggestions and inferences from the language model, we provide you with an estimation of a match. And we figure that out during post-processing by looking at our corpus data using nearest neighbor filtering, using an Elasticsearch cluster that lives alongside the model serving. When we train the language model, we also produce a content matching repository. So when you get an inference back from the language server, we go off and look at like what was the thing that probably contributed to this match result. And we can show it to you in VS Code, just like you're seeing here. The other thing that we're doing in the background that I mentioned earlier is post-processing and contextual awareness. We do this, we sort of gobble it up and we use it to help aid in the inference by giving the right variables and context, and we throw it away, we don't persist that. But in that, we can give you true contextual awareness of what operating system you're touching. Are you installing it on RHEL or some silly distro like Ubuntu or something like that? We know what you're trying to do, and if you are doing something like managing AWS and Azure, we can sort of go back and forth and give you that contextual awareness. This is really powerful also, not groundbreaking, but this goes back to what I was talking about before, right? Which is very specific and very targeted expertise and capabilities. This is why we think this is really the future of generative AI. Red Hat Ansible Lightspeed with IBM watsonx Code Assistant. These are the sort of 4 topics that we think about when we're designing and building the service. Where we're going from here is great. We can do task automation, but a playbook is probably built of dozens or hundreds of tasks. And so you need to be able to produce large volumes of automation, or at least a dozen or 2 dozen bits of automation, right? You should be able to generate whole playbooks or whole swaths of automation just by a natural language prompt. This is what we're working on today. You should be able to discover something because for the most part, all workloads that you could try to automate, somebody has probably already done this, and you just need to find the right thing that's out there and available to you. Content optimization is really important because even though Ansible is very easy to use, in spite of its YAML upbringing, there's still sometimes better ways to do it. And sometimes you can't just fall into that organically. You might need to be led into it or suggested the way to do it. And if you're a new developer, automation developer coming into a code base, maybe you've got 500 or 1,000 lines of Ansible code, and you're like, what does this even do? Please tell me what it does. And so that's where we're heading today. What really comes next, though, for customers who might be using Lightspeed, so like I said, today you can use this already. You can go install the VS Code plugin, turn on Lightspeed suggestions, and it will take you over and you can log in with GitHub or your Red Hat account. But where do we actually want to go from here? If you're a customer of the Ansible automation platform, it might not be good enough to use the community's content, right? To go out to Ansible Galaxy. Because maybe you do something really bizarre like manage ZOS. I've never even seen a ZOS system, but maybe somebody does. Or maybe you do something really obscure. Maybe you write your own modules, your own content to do very specific things like IoT devices or edge devices. You should be able to train the language model with your own content that you've built. If you're a large enterprise organization, like Kyndryl was up here earlier, is the Kyndryl gentleman still here? Well, Kyndryl has tens of thousands of job templates, a mountain, an absolute mountain of automation content and automation content developers, right? That's right. And how do you train and teach people how to build Ansible using your own best practices, using your own policies, using the modules that you recommend? Maybe you have one way that you install a database and there's no other way that somebody should install it. So what we're working on right now is training individual customer language models and hosting those using IBM's watsonx platform. But even looking beyond that, if you're familiar with Ansible Automation Platform, you know that we just announced event-driven Ansible. Event-driven Ansible is a way of taking observability and information and using it to make automation decisions based on playbooks that already exist. What if we could push observability data and event data into the same Lightspeed system and use it to generate automation on demand using expertise in repairing self-healing systems? I'm not saying that's a 2024 thing or even a 2025 thing, but This kind of thing enables that. Very specific, very targeted, very purposeful AI. And that's where AI is transforming into. Thank you.